All right, class, and this is the last video on section 6.3 in your note packet, Riemann sums. And so we are picking it up at the top of page 83. We're going to work the last two examples in your note packet. So in example 2 here at top page 83, you're instructed to compute the Riemann sum for f of x equals x squared plus 1 using 3 equal subintervals over the interval from 1 to 10. Remember, these are the values of x, so this is for x from 1 to 10. So so the function is f of x equals x squared plus 1. So this is the graph of the function f of x in red here, and we're going to calculate, we're going to estimate the area under this curve and above the x-axis from x equals 1 to x equals 10. And I have a vertical line here at x equals 10. So this is the area that we're going to estimate. So we're going to use 3 equal subintervals. So that means the number of triangles n is equal to 3. And since we're looking at x equals 1 to 10, a is equal to 1, b is equal to 10. And so delta x, the width of each triangle or each rectangle, turns out to be 10 minus 1 over 3, or 3 units. So each rectangle has a base of 3 units. All right, so we're starting at x equals 1. So the base of the first rectangle, right, starting at x equals 1, and the width of each rectangle is 3 units. So starting at x equals 1, the first base of the first rectangle goes from 1 to 4, and then we add 3 to 4 and we get 7. So the second rectangle goes from 4 to 7, and then we add 3 to 7 and get 10, and so the third rectangle goes from 7 to 10. So in part A here, we're going to calculate the left-handed Riemann sum. So we use the left number in each subinterval for our value of x, and then we calculate the value of the function at each of those values of x to get the height of each rectangle. And so the first height of the first rectangle is f of 1, which is equal to 2. The height of the second rectangle is f of 4, which is equal to 17. And the height of the third rectangle is f of 7, which is equal to 50. So now to get the total area of the 3 rectangles, right, we just add up those 3 numbers and then multiply that sum by 3, and we get 207 square units. So using the left-handed Riemann sum, right, the total area of the 3 rectangles is 207 square units, and that's our estimate with the left-handed Riemann sum of the area under the curve and above the x-axis from x equals 1 to x equals 10. All right, in part B, we got to do the same thing with right-handed Riemann sum. And so we use, in each subinterval, we use the right number, 4, 7, and 10 for our 3 values of x, and then calculate the corresponding values of the function for those 3 values of x to get the heights of the 3 rectangles. And there's 17, 50, and 101 in this case. And so when we add up those 3 numbers and multiply by 3, we get the estimate of the area under the curve and above the x-axis using the right-handed Riemann sum, which is 504 square units. So with the left-handed, it was 207. With the right-handed, it's 504. All right. Example 3 is a little bit more complicated, right, because of the math, but it's the same principle. We're going to compute the Riemann sum for f of x equals x cubed using 5 equal subintervals over the interval from 4 to 8. So x goes from 4 to 8 in this case. So here's the graph of f of x equals x cubed, and we're going to estimate the area under the curve and above the x-axis from x equals 4 to 8. And so I got vertical lines here at x equals 4 and x equals 8. So it's this area in here that we're going to estimate. All right. So 5 equal subintervals means the number of rectangles n is equal to 5. A is equal to 4 in this case, B is equal to 8. And so the width of each rectangle in this case, B minus A over N, is equal to 8 minus 4 over 5, which is equal to 0.8. So the width of each rectangle is not a nice even number, okay, or a nice whole number. It's a decimal. It's 8/10 of a unit. So that makes the math a little bit more complicated. So our rectangles, right, the left edge of the first rectangle is at 4, right, starts at 4, and when we add 0.8 to that, we get 4.8. So the first rectangle has a base from 4 to 4.8. Then you add 0.8 to that, and you get 5.6. So the second rectangle goes from 4.8 to 5.6. Add 0.8 to that, you get 6.4. And so the third rectangle goes from 5.6 to 6.4. And then continuing that fashion, right, you get the subinterval for the fourth rectangle and the subinterval for the fifth rectangle. Alright, so in part A, we're going to do a left endpoint Riemann sum. So we use the left number in each of these intervals for a value of x, and then we calculate the height of each rectangle by evaluating the function at each of these 5 values of x, and you can see we get some interesting numbers. And so these are the 5 heights of the 5 rectangles. And so to get the total area of the 5 rectangles, we add up those 5 numbers and then multiply by the width of each rectangle, which is 0.8, and we get the area of the 5 rectangles is 788.48 square units. So using a left endpoint Riemann sum, 788.48 square units is our estimate of this area over here under the curve above the x-axis from x equals 4 to x equals 8. Now we got to do the right endpoint Riemann sum. And so we have the same 5 subintervals, but now we use the right number in each subinterval for a value of x, and then calculate the value of the function at those 5 values of x to get the heights of the 5 rectangles. And now we add up those 5 numbers and multiply by 0.8 to get the area of the 5 rectangles. And the area of the 5 rectangles is 1,146.88 square units. So the area up here under the curve and above the x-axis from x equals 4 to 8, using a right endpoint Riemann sum, we get an estimate of that area of 1,146.88 square units versus the 788.48 square units using a left endpoint Riemann sum.